a label and you don't have a label, you only have this number that you put in your calculator, and you didn't put it as feet per second, the label itself is worth a point. So if it's a 4 or 5 point question, when I told you where all those points are coming from, that's what I'm going to be looking at. When I look at a question like number 9, and I'm not going to do the whole thing, we'll come back to it towards the end if we have time, but you ran 3 miles. That's all you know. And the question says, if you run 3 miles, how many hours did it take you? You know your answer has to be in hours, length hours. All you know is that you started running 3 miles. If you're training for a 5K, maybe you're running 3 miles, right? 3 miles, I have to convert it to what? What's the only thing I know about miles? Well, we know that we go 90 feet per minute, and that's about it. So we have to change miles to feet. So our conversion of miles to feet. And my unit now would be in the right unit. And I put in my numbers. I put in the 1 and I put 5,280 feet. Well, right now my answer is in feet. I don't want to know how many feet, but I know that I went 90 feet. And I want to cancel that unit feet. So I have 90 feet in 1 minute. At this point, I know how many minutes I have been running. If I asked how many minutes, this would be the perfect amount of work for you to have. But it said how many hours, so I have to do one more conversion. And I have to put the word minute down here and hours. And I know that 1 hour is 60 minutes. So that now I have 3 times 5,280. My feet canceled, 90 feet per 1 minute. I'm going to get my answer in hours, and that's how I get that number. Yes, question? Why do you dollars per hour, not $8.75 per 1 hour? I want to know that when I get done with this problem, I want to have dollars. I'm going to keep my dollars in the numerator, but I want it to be in 1 year. And someone said, oh, I know how many days in a year. You have to use this information. That you're working 52 weeks in a year, 40 hours a week, the 875, you have to use those numbers. You have to show me these as conversions that you're multiplying, okay? And I put a lot of those answers in the back, but that's what you're looking at. So this is what we put up on Friday. 10 questions, 50 points. We're going to look at lesson A5 right now. So make sure if you need to take a look at that from the notes and turn back to the beginning where we are looking at your notes. Yes?
Are we going to get like a homework sheet with all this on it?
No. So the question is, are we going to have an extra practice other than what you did last night? Usually that would have been the practice, that assignment. So that's why we're not handing it in, so you still have it. Plus you have all your matrices and all your homework from before. If you want yours back, I can get it to you. I'll just need to look at it. Just make sure you ask me, okay? So as we take a look at this, we are on page 15, 14. Page 14. As you look at page 14, here are our standards that we are taking a look at. So if I'm looking at my standards, at the top that I can write an equation that models a problem, I need to be able to do that. I can interpret solutions in the context. You can be asked to do that. I can apply order of operations and inverse. Some of you, when you did your homework on that A1, you didn't really show me any inverse operations. I wasn't too picky on that one, but just making sure you're understanding how to do that. And here's a big one that I'm going to ask you to do, justify my solution in the process. Next year in geometry, you do this a ton. It's called doing proofs. But justifying just means giving a reason. Give the reason that you're doing something, right? And a lot of them are actually properties in mathematics. And then we're going to be asked to solve. And here, this part with the linear coefficients and with having equations with coefficients that are letters, that's going to be more with our literal equations, which will come later this week and next week. This is not going to be on tomorrow's quiz. But if we are taking a look, wasn't that first problem ugly? And you got distributive property, right? You got more distributive property. You got adding like terms. You got fractions. We want to eliminate fractions. So it's how do you solve a question, an equation like this? What's the process? And we do want a process. So we're going to start with the simpler problem, right? When you take a look at this problem, we are going to add our like terms. So the justify looks like this. So if right behind here, it's just giving the reason for the step. So in this first one, if my first step would be to write 5 equals, I'm going to add 5m plus 2m. 5m plus 2m is not 7m squared, and it's not 7, it doesn't just become, when we're looking at those, we are adding our like terms, so you're adding the 5 plus 2. And 5 plus 2 gives us 7m, not m squared. We still have minus 23. The reason we did that first step is because we were adding like terms. So if I ask you to give a reason, what was the reason for going from the first step to the second step? We added like terms. Please write this down for right now for the justify, so you know what I'm talking about. Next step is we want 7m by itself. And when I want 7m by itself, what am I going to do, Joy? I'm going to add 23 on both sides. This one's going to work out really nice. I'm going to add 23. When I add 23, I am going to now have 28 equals 7m. How I got from this step in the black to this line down here in purple was by doing the addition property of equality. Addition property of equality says if you have an equation, I can add the same thing on both sides and I have a similar or equivalent equation. These two are equivalent. Last step, if I'm looking at this, what are we going to do next? Did you look at it?
You divide 28 by 7.
And it says we're dividing 28 by 7, but we actually want to divide both sides by 7. We're going to do it on both sides so that we get 1m. Remember, your goal is to find out what m or 1m equals, okay? So if you only divide on this side by 7, you really have 7m left on this side, right? So in this case, we get m equals 1m equals 4, or if you just want to write m equals 4. I take it either way, I don't care, okay? But when you get to this point, the reason that we did this last step was because we did division. So it would be the division property of equality. Do I really need to write this down? You're going to be asked to give the steps. So to the side, if you didn't write down these three, adding like terms, addition property of equality, and division property of equality, please write it to the side. We'll wait for you. At 4 is the right answer for this, because on the quiz I can't turn and look in the back like you can on your homework. What are you going to do? I'm going to replace m with 4. So in the original equation, so please write down check, because as someone in the last class asked, is it optional? No, I'm going to assign you to do it for at least 3 or 6 questions in your homework out of all of them. So, Bree can tell me what I should write.
5 equals 5 times 4 minus 23 plus 2 times 4.
So, going back to this exact original equation, I'm replacing the m everywhere. Some of you aren't writing the check, write it. Minus 23 plus 2 times replacing the m again with 4. I don't care if you put it in your calculator, if you do it in your head. 20 minus 23 is a negative 3. Negative 3 plus 8 is 5, right? Does it check? This checks. You could have put it in your calculator also, correct? Okay. So, if you didn't write down the check, please do so now. I am adding like terms. Jonah, on this first question, what do you have when we add our like terms together? I have 11m minus 6m. 5m. So I have 5m minus 8 equals 22. Jake, on the other side of the equation, what am I going to have when I add on this second equation, what am I going to have when I add my like terms here? 3y plus 5. Okay? So both of them, the justifying would be the same. I added like terms. That's what we did on both sides. Okay? I would agree, if you told me your next step was that you did the addition property of equality, I would take that for both of them. Addition property of equality. Now I had someone say that, yeah, aren't you really subtracting here? But when you subtract 5, Isn't that the same as adding a -5? Isn't -5 and plus a -5 the same thing? So I just want you to be aware that I would take subtraction property also, okay? If you wanted to put subtraction because you like to subtract 5, but someone else puts plus a -5, just keeping in mind that that is the same thing, right? So subtraction property of equality or addition. Over here, what would I be adding? 8, right? Like I said, we're not going to check every single one of these, but if I'm doing 5m, -8 plus 8, that's 0, equals 30. Over here I have 3y is equal to 14 minus 5 gives us 9. Once I have that, my last step for both of these would be division property of equality. Division property of equality says I'm going to divide both sides by that same coefficient of y, which is 3. Here I'm dividing by the, so this should be relatively remembering your review that you've done. Second one, m equals 6, and over here we had y equal 3. We're not going to do a check of these, but you do the check in the same way, right? You replace the m here with 6, here you replace the y with 3. So there's going to be 2 questions in your homework, or 3 questions in each section where I ask you specifically to do the check, and I'll be looking for it, okay? So, next problem, writing multi-step equations. Now, some people are like, you mean it's that simple when we do it? Don't make these harder than you have to. It says no one caters shopping for new guitar strings. Noah buys 2 packs of strings. Kate buys 2 packs and a music book. The book costs $16. The total cost is $72. Write an equation that models it, then solve the equation to find, what are we asked to find? The cost of 1 pack of strings. So my final answer, you must tell me dollars, right? The cost of 1 pack of strings. So what does my variable stand for? X. It's the cost. It's going to be how much money you pay on that you spend on a pack of strings. So one of the first things you have to do is identify your variable. Okay. On the quiz, I'm going to ask you, not on this quiz, but on the test for this unit, identify your variable. What if you didn't want to use X? Could you have used C for cost? Sure. Could you use M for money? Sure. I used X. Now I want to write the equation. The equation, I'm going to do it up here because then I have a little more room. I'm thinking about Noah. What do I know about Noah? He bought how much? 2 packs. I don't know what packs cost, so he bought 2X. And then I'm looking at Kate. And Kate bought what? 2X plus the book is 16. And she spent 72. And someone will ask me for the quiz, Ms. Thompson, can I put 4x and then can I already have subtracted 16 from 7? No, write the equation for what they're telling you. We're talking about what Noah and Kate bought together and they spent a total of $72. That's my initial equation. Now, can you now solve it by adding your like terms and put 4x plus 16 equals 72? And then I'll have someone say, well, couldn't I have subtracted 16 first up here? Yes. Someone else might subtract 16 at this point, right? Does it matter when you subtract the 16? No. Subtraction property of equality or addition, adding a -16 is the same as minusing 16, right? This is 0. I'm left with 4x equals 15, 6. Divide both sides by 4. And I'm spending how much on a pack of strings? $14. So my solution, x equals 14, but my answer is going to look different. My answer is going to be $14 per pack of strings. Question? Hey, yes, give me more fractions. Anyone? No takers? No one? Just loving fractions? And I agree, most of you will make some very simple mistakes with fractions. So there's 2 ways of looking at equations with fractions. You're going to have a lot of fractions as we start off in these beginning equations, and you'll have them throughout the year. When you have a fraction, 3x over 4 minus, this is really 1x, right, over 3 if you wanted to think of it that way. And notice how they wrote that down here. They wrote it as 3/4 x minus 1/3 x, okay? they're going to get a common denominator. So there's two ways. This is method one. This is going to be method two of clearing fractions. I think students generally have a lot more luck with clearing fractions, but I want to show you both ways. Okay? When I add 3/4 minus 1/3 or subtract them, I need a common denominator. The common denominator is 12. So they took this first one times 3, right? To get 3 over 3, they get 9/12x. They took both the numerator and denominator here times 4. I don't necessarily need you to write that in and show it, unless you really need to write that down with fractions. So 9/12 minus 4/12, we get 5/12 times x. Notice they don't write it as 5x over 12, but they write this as 5/12 x. And the reason that they do that is because when you're solving an equation and you have 5/12, you can multiply by the reciprocal instead of saying, divide 10 by 5/12. Some of you, if I say take 10 and divide it by 5/12, that really means, remember, division changes to multiplying by reciprocal. That's what division is. Anytime you have division, that's the same as changing division to multiplying by the reciprocal, which in this case would have been 12x. So they just right away, if it's a fraction out in front of your equation, multiply by the reciprocal on both sides. 5/12 times 12/5 gives us 1. That's our goal. And on this side, 5 goes into 10 2 times. 2 times 12 gives us 24. Get the same answer this way. They took both sides of this equation times 12. When they do that, they have to take 12 times every single one. I want you to look at the equation that I have up on the board. Because they don't know their multiplication facts, but we're multiplying each one times 12. We get 9x minus 4x, we get 5x equals 120. Divide both sides by 5, and you get 24. These answers are exactly the same. One of these methods looks a lot better for some of you than the others. Like, if you can get to this problem, you like it a lot better than keeping all these fractions in. I don't care which way you do it. It doesn't matter to me. I'm used to doing it both ways. But some of you will struggle with fractions. So, we're going to look at these 3 questions right now. Okay? This first one, I want you to get a common denominator. What is my common denominator going to be? 20. This one, we are going to eliminate the denominator. Okay? So I want you to do it both ways. Here we want to eliminate the denominator. Okay? First one, if we're getting a common denominator, I heard someone say 20 is my common denominator. Do I need 20 over here with the 3? No, not this time. Sometimes you will, but not with this one, right? And I might put the a behind, right? So how many, it was 2/5, it's now going to be how many 20ths? 8. Everyone agree it's going to be 8? Okay. 8 20ths, because to get 20 we have to take 4 times 5. And instead of 3a, we are now going to have 15, because we have to take them both times 5. So we get 15a over 20. 8 plus 15 gives us 23 20ths a times a equals 3. And in order to solve this, I'm going to multiply by the reciprocal of my coefficient. What is my coefficient in this one? When I take a look at this problem, Kyan, what's my coefficient? 3 or 23 20ths? Coefficient. 3? 3. So I should divide by 3 on both sides? That help me get 1a. Remember, my goal is to get 1a equals. My coefficient is 23 20ths. I'm going to multiply on both sides by the reciprocal of 23 20ths. So 20 over 23. And on this side, this is 3 over 1. And I'm going to take it times 20 23rds. It's an ugly number. You can leave it as an improper fraction. 3 times 20 gives us 60 23rds. Now, you might check the back of your answers in the workbook or on the textbook, and they might rewrite it as a mixed number. You can leave it like this. I mean, unless you really like to change it to a mixed number, but some of you will make mistakes when you change it to a mixed number, so leave it like this, okay? All right, I'm going to show you on this way 2 different ways. Let's do the eliminate our denominator first. Eliminating the denominator here. What should I multiply every single one of these so I do not have a denominator? 7, 14, or a much larger number. What do I multiply by? Much larger. No. Let's go smaller. What's the smallest thing that 7 and 14 both go into? 14. 14. We are going to take 14 times 2m over 7, plus we're going to take 14 times 3m over 14 equals 1 times 14. It's kind of like the problem on the board at the beginning. We want to not have any fractions. Now at this point, I could just look at the problem and multiply 14 times 2 and get 28. But 7 goes into 14 how many times? Twice. So I'm going to cancel this out and I'm going to put a 2 here. This becomes a 1. 2 times 2m gives me 4m. 14 over 14, even better. 1 over 1, right? They both cancel. I'm trying to get rid of my denominator. I am now left with 3m. And 1 times 14 is 14. This is a much nicer problem, isn't it? Than what it originally was with all those fractions. So for a lot of you, writing it with a fraction, this is going to be a lot better. We're dividing both sides, and m equals 2. And if I was doing the check, that would give me 4/7 plus 6/14. Oh, I can simplify 6/14, right? It simplifies to 3/7, and 4/7 plus 3/7 equals 1. It checks, right? So I can still check my answer. Someone, when they did the first question in their homework, they were like, I'm not sure if I did this right. Turn and look at the answer key. I'm going to keep pushing you guys to do that. Some of you have never looked at answer keys. I don't know if you think like you're cheating, but if you don't check to do it and see if you're doing it right early on, and you do 15 wrong, it is like such a bummer, and then you have to redo them anyway. So figure it out right away. I'm going to show you this problem 2 different ways. The first way I'm going to show you is if you use the distributive property. You guys remember distributive property? Sometimes distributive property is great. The other way we're going to do this is just by dividing first. Now, I personally think to divide first in this method because I notice it's -2 times this whole parenthesis equals 24. And because 24 is divisible by -2, I am going to take this 3x plus 9, 3x plus 9 equals 24, the problem, and I'm going to divide them both right away by -2. And the reason I'm doing that is I get simpler numbers. -2 divided by -2 leaves me simply with 3x plus 9 equals -12. How do we solve that? We are subtracting 9 from both sides. Once I have subtracted 9 from both sides of my equation, I am left with 3x is equal to, let me put that away, and I want you to write these in your notes. If it works better, don't forget to pause. So when I take -12 minus 9, or plus a negative, I'm going to get a negative how much? 21. And I divide -21 by 3, not by 7. I was thinking what my answer is going to be. Have any of you ever done that? Like, oh, I know the answer is 7, so you put division by 7, you really meant 3, and the answer should be x equals -7, right? We're dividing both sides by 3. What if I would have done it with the distributive property? If you're doing this one with the distributive property, you are multiplying these out. And the most common mistake is people will forget to multiply the second one. But you're taking -2 times 3x plus -2 times 9. And I don't care if you use a dot or parentheses when you do your multiplication equals 24. And we get -6x plus 18 equals 24. And we've now subtracted 18. Ooh, wait, this was -2, right? This was -18. Should we be subtracting 18?
No.
No, we should be adding 18, right? So it's really easy sometimes, and you can see where my plus negative kind of got in there. So just be watching those signs. That's probably the most common errors. So negative 6x is equal to 42. Do I get the same answer? I don't care which way you do the problem, right? So sometimes you're going to have options. Sometimes you keep the denominator, sometimes you eliminate a denominator, sometimes you're going to have two different ways of solving your problem. You need to find what works best for you, but I still need you to show your work. So this is the homework that you're working on. This is where I say on this page, where you have 1 to 12, I need you to do 3 checks. I don't care if you check question 1, 2, 3, if you check 1, 4, 7, I need you to show me your check. What do I mean by the check? I mean that if I am looking at your paper, I see that you have h equals something, and then you are showing me that 19 minus whatever h was minus another thing, that was equal to negative 13, and I can see your work, because there will be a few quizzes that I ask you to show me your check, okay? So when we are taking a look at that.